Monsoons. Many locations on Earth experience prevailing winds that blow in one general direction for long periods of time, but then change course. Such seasonal shift in the wind's direction is called a monsoon. The term monsoon comes from the Arab word mausim, which means season. This changing of the direction of the wind can have a dramatic effect on both the weather and a population's way of life. Although monsoons are regular occurrences in places such as North Africa, West Africa, and Southeast Asia, perhaps the most famous monsoon of all takes place in India. The arrival of the rainy season, India's summer monsoon. Early each summer, two ingredients mix to create India's famous wet weather monsoon: cool, moist air from the Indian Ocean and hot, dry air over the country's landmass. Because this mix of ingredients is often just right, the monsoons that affect India each year are among the most potent on Earth. Between June and September, India will receive as much as 75% of its annual rainfall. The moisture that feeds India's monsoon rains comes from the Indian Ocean, a body of water that is constantly warm because of its proximity to the equator. As the sun warms the ocean, water evaporates into the atmosphere, creating clouds. An increase in direct sunlight caused by the arrival of solar summer in the northern hemisphere intensifies this process. Simply stated, more warm water means more evaporation to fuel the formation of clouds. The first important component of the rainy monsoon season, moist air, is now in place. The second ingredient in India's wet monsoon season is hot, dry air over the mainland. Because land absorbs more heat than water, the same seasonal warming trend that causes water over the Indian Ocean to evaporate is even more intense on India's land. Each spring, the sun's direct rays create heat that is stored in the ground, and warmer ground creates more heat in the atmosphere. This warming is intensified by the presence of the Himalayan mountains in the north. The Himalayas are a massive mountain range that contain many of the highest mountains in the world, landforms that create a barrier between India and much of the rest of Asia. This mountainous wall blocks the flow of cooler air into India from areas such as Tibet and China. As a result, each spring, temperatures in many parts of India regularly exceed 100 degrees Fahrenheit. During this time, the air is still and lifeless, but the stillness creates a sense of anticipation. Things are about to change. How do the moist air over the Indian Ocean and the hot, dry air over India's mainland combine to create the rainy monsoon season? It is important to remember that warm air rises. So each spring, as the hot air over India's mainland rises, it slowly pulls moist air from the Indian Ocean towards the land. At first, the arrival of this moist air brings uncomfortable humidity but little rain. But as moist air moves higher into the atmosphere, it cools and its water molecules condense, becoming too heavy to remain suspended in the air. The moisture falls to the earth as rain. India's physical geography also impacts the annual progress of the monsoon. The Western Ghats, a mountain range in the country's southwest, blocks winds and rain clouds arriving from the Indian Ocean. This ensures that the country's southwestern coast receives the earliest and most rainfall. This region has a tropical monsoon climate. The coastal town of Kundapura, for example, receives an average of more than 120 inches of rainfall during the monsoon season alone. Areas of India north and east of the Western Ghats receive less rainfall from the monsoon, and therefore are home to a variety of drier climate regions. In addition to blocking the arrival of cool air from other regions, the Himalayan mountains are the final barrier to wet weather from the monsoons. They keep virtually all rain from the monsoons in India, and their northern slopes receive little annual precipitation. The winter monsoon. Each December, the monsoon changes direction as the northern hemisphere's solar winter arrives. Since solar winter is the quarter of the year when a hemisphere receives its least amount of sunlight, India's land and the air masses above it begin to cool. There is no longer any hot air to pull moisture from the Indian Oceans. As a result, the winds begin to change direction, blowing from India's land instead of toward it. The dry monsoon season of January and February begins. Although there can still be precipitation, rainfall totals decline dramatically. In fact, much of India experiences drought conditions during the winter monsoon season. Predicting the monsoons. During the time periods bridging the monsoon seasons, Scientists collect data to predict how much rain the country can expect during the next wet monsoon season. The India Meteorological Department releases forecasts in April of each year for the four geographical regions of India. These predictions are important because monsoon rains are vital for the agricultural economy of India. More than 50% of the farmland in India relies on rainwater alone to water the crops. Accurate forecasts help farmers know what to expect for each growing season. The Indian monsoons are the lifeline of India. Due to the unique geographical features of the land, monsoon winds protect the land from becoming a desert environment. So, next time you hear about a monsoon, don't just think about rain and floods. Think about a great wind that helps propel a country.